Okay, so we're going to prove the power rule for logarithms. We're going to let b and m be positive real numbers with b not equal to 1, and we're going to let p be any real number. Then we know that log base b of m to the p is equal to p times log base b of m. So what we know is if we have log base b of a real number, a positive real number, raised to any real number, we can actually move that real number from this exponent slot to the coefficient slot in front of the log base b. And then it's just log base b of m. So let's go ahead and start this proof. Okay, so first we're going to let y be equal to log base b of m. Of course, we know this is equivalent to b to the y is equal to m. Okay, so now what we're going to do is we're going to raise both sides to the p so we can get that m to the p. So this implies that b to the y raised to the p is equal to m raised to the p. We're going to use that rule of exponents, where this is the same thing as saying b to the y p is equal to m to the p. Now, what we can do is we can take the log of both sides of this equation. So this is the same thing as saying log base b of b to the yp is equal to log base b of m to the p. Okay? So the inverse rule for logs states that log base b of b with the same base raised to something is just that something, right? It's just y times p, and then that's equal to log base b of m to the p. And I can illustrate why this is equal to this really easily. So let's just draw a little box. So to illustrate that this is not part of the proof, right? So we'll let x equal log base b of b to the yp, right? We know this is equivalent to b raised to the x is equal to b to the yp. Of course, b to the x is equal to b to the yp. This implies that x is equal to yp. And then, of course, we originally had x is equal to log base b of b to the yp. So that means yp is equal to log base b of b to the yp, right? So that's how I can go from log base b of b to the yp to y times p, right? So let me close this box to illustrate that this was not part of the proof. Okay, now we have this equation here. Remember, okay, first thing, I'm going to use the commutative property. I'll have this be p times y is equal to log base b of m to the p, because y is log base b of m, right? So this implies that p times log base b of m is equal to log base b of m to the p. And of course, equality is symmetric, right? So that means instead of writing this, I can write log base b of m to the p is equal to p times log base b of m. And that is exactly what we wanted to show. Log base b of m to the p is equal to p log base b of m. And that is the proof of the power rule.